Hello, my name is John Blake. I am a member of Team 1, the Software Engineering Capstone, Graduate Capstone for the fall 2024 semester, and I'm here to present my team's real-time bus monitoring system project that we made for Gwinnett County Public Schools. The agenda for this presentation will go over a breakdown of the team members, who we are, an introduction of our project, then talk about our milestones that we completed, a brief overview of that, with some more in-depth work completed for each milestone, a bit of a demo, and then final conclusions. So our project description goes like this. Our project is a simulation of producing and consuming telemetry data for school buses through an event stream. We utilized Apache Kafka to create a data pipeline of sorts between a synthetic data producer and a consumer. This pipeline would be an improvement over GCPS, or Gwinnett County Public Schools, current process of streaming and getting their bus telemetry data. Right now they make API calls to Samsara, that's the data producer, if you will, every 5 seconds to fetch this data, which obviously comes with certain latency issues. So moving to a data pipeline would give GCPS real-time insights into bus locations and speeds, obviously with less latency concerns than making API calls, and it gives real-time visibility into the punctuality and safety of the buses as they drive along their routes. So our simulation that we made is a proof of concept that uses Kafka as a data producer or data pipeline. It takes data from a producer, and the consumer would consume data and parse that into a database for analysis. And then we have UIs to do system monitoring and data visualization. On the right hand, there's a team breakdown. Yunsek was our lead Python developer. Hudson is our Python developer and DevOps engineer. He did the containerization for the project. John Blake, that's me. I'm the project manager, team lead, and Python developer. Julio is our infrastructure lead and DBA. And Tiep is our UI developer and DevOps engineer. Our milestone started off with a kickoff in August 19th. We had a first milestone, you see there, in September 16th. The second milestone was in October 14th with the database interaction. The third and final milestone was in November 11th with the containerization, and then we have the final deliverable for the 18th. That's a full breakdown, and we'll go over the milestones and what each of those encompass, but this is the timeline. This is an overview of the application architecture for our project. You can see there's a producer written in Python. That's what produces synthetic data to the topic. You have the consumer that pulls and consumes the data from the topic and writes valid events to the database. There's also the monitoring application that surfaces or takes the data surface from the database and visualizes it. This is all on Linux. So our milestone 1 involves creating the producer, the consumer, and Kafka connector. The producer, again, that's the module written in Python that generates synthetic data, either in a random or bus route manner. You have the consumer, that's what consumes records from Kafka. The event data gets parsed, validated, and smoothed as events arrive. And then you have the Kafka connector, which of course acts as the event stream between the two. Then for milestone 2, we added a database layer along with a monitoring user interface. The database stores tables for both the producer generated data, so this is the tables for event data, location data, and speed data, and then some one-time load data for the purposes of the synthetic producer. So data on the schools, routes, bell times, drivers, etc. There's also views to surface the data that the UI uses, and a stored procedure that the consumer calls to insert data. That is all in the database. Then there's also the monitoring UI. This is a simple UI made using Flask and Python to view routes and event data on an interactive map, followed with some metrics to inspect the health of the Kafka Zookeeper and MySQL instances. Then finally, for our milestone 3, we did containerization, testing, and some improvements to our monitoring UIs. We did containerization using Docker and Docker Compose. You can see our strategy there. We did testing. We created 2 test suites for the producer and the consumer, respectively. And we also did stress testing on the entire project to identify bottlenecks. Then we did monitoring improvements. We added Prometheus and Grafana. Prometheus is a tool that we're using to pull data from the Java virtual environment, where Kafka and Zookeeper are running, to get important data on the health and the integrity about Kafka and how it's withstanding. And then Grafana uses Prometheus as a data source, which provides better visualizations for the metrics that we're interested in. So to go ahead and give a demo of our project, I'll go ahead and start our data producer here. This is going to generate a bunch of events and send them to Kafka. So as it's generating all these events, on the right-hand side, I can start our data consumer that's going to consume events from the Kafka topic. So we're going to see a whole bunch of events being consumed until it'll eventually get caught up here with the producer here. It's consuming all these events. So you can see that this is obviously the events are being produced inside the producer, sends it to Kafka, and then the consumer is consuming the events in Kafka. So that's the basic event stream. As far as the visualizations, we do have Prometheus here, and then we'll go over to Grafana to check that out. In Prometheus, you can type in all kinds of different expressions that you want to search for to get insight into everything from bytes in, bytes out, number of messages, valid, invalid, and total. Many different queries that we can execute here to get info. We'll just do bytes out as an example. And you can see the graph breakdown within the last hour. That's obviously what we just did now. That's this bump in the graph here. You can rearrange the chart here to get a different time range. You can check out a different query as well, like maybe bytes out. I think our time range was 1 hour. So it's obviously the amount of bytes out as well. Jumping over to Grafana, there's a bunch of other visualizations that we can get. It uses Prometheus as a data source, and this gives us access to a lot of other neat visualizations that use the data from Prometheus as the data source. So all of these here, and these are still a work in progress, but these would be our UIs essentially to do the monitoring for the application health with many different metrics regarding the memory and the JMX, how it interacts with the Java virtual environment, getting the health buffer, and so on. So, to conclude, normally there would be Q&A here, but for the purpose of the video, we'll give some final thoughts. The project itself is complete. The handoff to our client GCPS will be done within the week, and they will utilize our project here as a proof of concept for how they could utilize Kafka as an event streaming tool in their own IT systems. Ideally, this project would serve as a point of reference for how they could use a Samsara Kafka connector to connect their existing IT systems to Samsara and create an event stream. And ideally, this would resolve the bottleneck they currently have with their API calls. As far as where this project has room for expansion, since this serves the purpose of a proof of concept, if you will, it's not really necessary to add improvements. The core of the project itself is just demonstrating the abilities of Kafka as an event streaming platform, which it succeeds in. So that should conclude our project. and this presentation. Thank you for watching.